Well, this one's for you, George, because I just realized how funny I am. When I think about studying tetrayonics, what do? I go get a really thick piece of paper, stack of paper that is, and I say, let's fill that thing up with notes. A few weeks later, I actually have some notes. It's not quite that thick. Well, yeah, I mean, it's getting there. So I'm working on my introduction. This is maybe represents 10 minutes of the conference ideas that I've not really put on paper just yet. I mean, on the computer just yet. Obviously, I don't know how not to start with if the mathematics is the language of science, and equilateral quanta geometries are the grammar that the math must follow. Now, what the standard model lacks is a rigid geometry to guide its principles. So, basically, what I'm going to cover briefly is the tetrayonic terminology. And what I mean by terminology is it's just another name for specialized vocabulary. And Kelvin had to go into physics and create a few new terms and distinctions and differentiations. And we're going to talk about those so that you can approach the tetrayonic materials with a fresh perspective and a good understanding of where to start. So, we're going to refresh our memories a little bit regarding terminology and grammar. Um, Now this isn't really going into the conference yet, but it might. I don't know. I haven't thought about it. I'm going to use quotes, but you know, all of us want to be thought cultured. This desire is natural, wholesome, and human. But there are other reasons for the urge to improve our command of English. So we got to really be specific about our words, and this is where the square numbers and the triangular numbers, it's kind of where this comes in. And we're all just stumbling through the forest, blah, 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 sharing the asylum, the left brain and the right brain people. So these are just ideas that I have. um, let's see, what am I looking at here? Not real sure. Oh, it's a revealing moment when you realize for the first time that speech is not instinctive, that it is habitual, and that it is learned. So, like a child imitating parents. First words. And my son was all the time. I know that's not really a word, but he was 9 weeks old and he answered a question. He goes So grammar, physics, it's the triangle. So um, okay, what I'm saying here is that the mathematics is behind that of the English, and so by using geometry, we're privileged understanding. And so we've got some stuff that's not, unification of the language. There we go. So this is kind of a bonus. A unifying theory should have a true understanding of the language. I think we've talked about this. Anyways, I was thinking about doing a juggling act during the Tetraion Genesis. If I can make some good tetrahedrons and make 3 of them so I can show my electron and make 3 of them so I can build a quark, I might start juggling those on stage if I get comfortable enough. So I think we covered that. Anyways, it's just some thoughts. Along the source of mystery, the revelation of geometry is the basis for the physical constants. This reveals the relationships between matter, energy, momenta, charge, and all the other measured constants. Now, I don't think this is going on in the conference, but obviously we're going to talk about the bottom up versus the top down. What I said here is explanation, extrapolation, investigation versus the Newton's observations. It led to patterns that were useful, of course, but it didn't quite allow for a true understanding, and Newton himself wouldn't interpret his results. So, I guess you can all kind of look at this as like, pretend like you're watching a Star Wars movie, and I'm actually teaching you the real deal of physics, and you're just watching a movie, and the student for the first time is trying to pass his test, okay? I'm just trying to tell stories. We got to create a narrative. This isn't my conference presentation. I'm just talking, man. Just giving you some ideas. Critique it away. So obviously this is a dream come true for me, but even more importantly, I believe that this will eventually be a dream come true for you and the community of brilliant minds that sit before me. I have a few more things to say on this point, such as if I also hope that this presentation helps to excite you to realize there's a younger generation still seeking these answers and still doing this research. There's amazing minds of all ages, don't get me wrong, but it is important to focus learning, capability, abstract thinking onto our children and the youngest we can get. And I'm a proud father of a 4-year-old who can show me what a tetrahedron and a cylinder. And he's like, Daddy, can you please turn tetraionics off? Daddy, can you talk to Kelvin Abraham a little later? Pretty funny stuff. So anyways, another thing we say is English sucks, math is okay, geometry is king. Again, this goes back into the bottom-up approach of things. So one main takeaway of tetraionics, yeah, okay, here's the bottom-up approach, blah, blah, blah. We're just saying the same thing in different ways right now. Alright, and then we get into, obviously, the distinctions. There are many layers, not immediately apparent to the first-time onlooker of the theory. Now, we have to understand that photons represent H frequency. Bosons have to represent H nu. Nu as in number, Max Planck's nu. What we end up over here, obviously, we have 9 triangles. We'll see this right over here, and we'll have 3 triangles running across the middle here, 1 triangle up the top. So you see here, we already have 1, 3, 5. If you look going across, those are odd numbers right here. And this is the bell curve, 1, 2, 3, 2, 1, if you're looking up this direction. So we represent the odd number acceleration or deceleration curves of particles based on how many quanta are available to exert a force. And square numbers over here, so like mv squared for energy. Leibniz is the first person to understand or describe energy as a scalar quantity. And if you look real closely, this 3 runs up the top, and we know 3 squared is 9, or square root of 9 is 3. And we can go ahead and move on, and as we begin to connect these dots, it becomes increasingly apparent that in our universe is geometric in expression as opposed to mathematical in nature. Now let me say that again. I know I'm going really fast, but I have a 10-minute time limit. I'm just going to see if you can keep up. Anyway, as we begin to connect these dots, it becomes increasingly apparent that our universe is geometric in expression as opposed to mathematical in nature. We've got square numbers, but we really need to call them triangular numbers, and this is why. Okay, these are triangular numbers, but they happen to represent square quantities that we're used to saying. Okay, square, square, blah, blah. This is the equation for that, sum of 2n plus 1, or sum of 2n negative 1. These 2n plus 1, 2n negative 1, these are odd numbers. This represents an acceleration or a deceleration of the particle. Odd numbers add up square numbers. See, we're going to spend some time. Here's a normal Bell-Dillich distribution. We start with 1, then we go 1, 2, 1, then it's 1, 2, 3, 2, 1, then it's 1, 2, 3, 4, 3, 2, 1. This is the bell curve. This is where the probabilities of quantum mechanics arise, and the photon distribution is expressed in the patterns that develop. It's really quite fascinating. Anyways, let's get really excited for a minute. Now, this is awesome. This is the periodic, like the formula for elemental periodic. I'm missing the term right now. But 2, 8, 18, 32. But then you repeat 32, 18, 8, 2, and you end up with 120. I forgot to add the 20 because I just knew I was right. Hey, I forgot to add the 20, but I knew I was right. You add this up, 16 plus 4 is 20. You carry the 2, 6, 7, 8,